All right, welcome to the Audio Programmer Meetup, April edition. And I'm so glad that you're able to join us here. We do this every second Tuesday of the month. And just a couple quick announcements before we get started. We would like to thank our sponsors for the Audio Programmer Meetup who helped make this possible, Focusrite and Sonics. So thank you to our sponsors. And also, if you enjoy this discussion, maybe you happen to drop in here randomly, or maybe you're a seasoned audio software developer and you want to continue the discussion and get involved and learn more about this exciting world that we're in, come join us on our audio programmer community. You can join us at theaudioprogrammer.com/community. We also have a number of jobs and contracts that are available as well, and you can find out more about that on our website, theaudioprogrammer.com. And with that, we'll go ahead and get started. So about a month ago, I did a video where I had just gotten a Windows computer and started doing audio software development on Windows. And going through that experience, I wanted to show people and walk people through some of the tools that I was installing to help set up my developer environment. And while I was doing that, Pete, who is from Microsoft, happened to comment, and he had some more suggestions and some further comments on how you can actually get your developer environment set up and all these different tools. And so Pete was nice enough to come on to the meetup with us today to talk about that. And he also sits on the chair for the MIDI Association, and he can give us some updates on what's happening in that world as well. So with that, I will introduce Pete. How are things going?
Thanks. Thanks for having me on. And this is exciting. This is the first meetup I've been part of, so I'm really excited to see how this goes with folks here. And again, thanks for the invite on this. I thought your other video was really good, and I was watching and I was thinking, oh, you need to use this tool right here. It'll be so much easier if you just do this or if you just do something like that. And so that's great to be able to come in here and talk about some of the cool things that are happening on that. Um, for folks who don't know me, you started with some intros there, but yeah, I am a an engineer at Microsoft in Windows on the developer platform team. I tend to focus on MIDI right now for a good chunk of my work, but I'm also doing a lot of general developer platform stuff. And some of my sister teams in the organization are doing a lot of the developer productivity things, stuff like the Windows subsystem for Linux and the terminal and PowerToys and a bunch of other things we'll talk about here. So I thought we'd throw a little bit of love their way and show some demos of that and show how they can help you with some of your setup. And you and I were having a good conversation before we started here, talking about kind of like the tone of this and whatnot. Um, and you had some good thoughts about hey, is this a Mac versus PC thing, or like what are we going to do there? Like, you want to talk about that for a second?
Yeah, absolutely. So I'm an avid Mac user myself, and one of the challenges that we have here in audio software development is that if you want to develop plugins or audio apps for Windows, you have to have a Windows machine to develop it with. And that one thing that I've found just in the Windows development, and as a person that came back into Windows after probably 15 years of being on Mac, is just how great the experience has been, actually, and that it really is two different tools that are in your toolbox, and that we're not here to debate which operating system is better, or a lot of people, they put their personal identity into these operating systems, don't they? And at the end of the day, these are just different tools for different purposes. So with that, we're really here to help people develop better audio apps, and to be able to do that using this tool, which happens to be the Windows operating system. So if anybody that has any plans of coming into the chat saying, "Oh, Windows stinks. I just use Mac," you can save yourself the effort, because we're all about positivity here and just trying to help each other. So yeah, so I thought that maybe one thing that we could start with is just getting to know you a little bit better. So you were telling me a little bit about your background, and I thought it was really interesting. So maybe we could start just before we get into the Windows, just telling a little bit
Yeah.
about the developer journey, and and you as a developer?
Yeah, so I won't bore people by going all the way back, but I will just say that I started on the Commodore 64 and doing like SID chip programming when I was like 12. That was kind of where things started. And then way after that, I started working at a music store when I was in high school, selling rolling keyboards and D50s and things like that, and a bunch of those things. But once I started getting out into professional world, I did a lot of programming for a local company where they would contract us out, set up projects at different companies, and it would be a different project every 6 to 8 months. And I'd mentioned working on, because you said you're from Florida or in Florida. And we worked on the Florida Department of Law Enforcement evidence management system. And I won't go into the gory details of things that we saw down there, but there's some serious CSI type stuff going on behind the doors in terms of what they just have laying out on the tables in those places. But it was really fun and doing that, I taught Visual Basic in France for a couple of weeks as one of it was kind of funny. My first experience with that is they said, "Hey, you're going to go over to France for a couple of weeks and do some programming to help these folks convert from their mainframe stuff to Visual Basic. No problem." I get over there and the guys ask me, "Okay, where's your curriculum?" I was like, "What? My curriculum?" Like, "Oh yeah, this is 2 weeks of training for, moving from Visual Basic to something like this." And this was like 1997. And so I had to like go buy a dictionary for all the technical terms that they never taught us in, college and high school French and all that kind of stuff and going through those. So they're really kind of a lot of fun, different types of projects like that. Um, some less stressful than that actually. And so most of the work I did was Visual Basic early on, then C Sharp later on, almost no C++ at the time because these were business applications for the most part. And then in 2009, I started working at Microsoft, doing a lot of different things. I ended up working with a lot of music industry companies for a while and started having some success working with them. Like, hey, here's how you can do things on Windows, and hey, here's how you can make your DAW run a bit better on Windows if you do threading this way versus that way, or you do some other things there. So I had a lot of those conversations and then just kind of continued with it and made it my job. It was one of those things that as long as it was successful, people let me keep doing it, which I always thought was fun. And then partway through that, I joined the MIDI Association as our representative because one thing at Microsoft is we have reorgs like constantly. Like the teams change at least every year, sometimes every 6 months. And so all these partners that we're working with in the audio industry said, "Hey, do you know this person? That's who we were dealing with." And it's like, "Oh no, they're in a completely different group now that like completely unrelated." So I tried to stay on to be like a single consistent face no matter where I moved to, so companies knew who they could reach out to, which you wouldn't think that's the biggest challenge, but that was really one of the biggest challenges. And then I started getting back into doing more engineering as part of that as well, and started, you know, forwarding it to pretty recently here. Proposed that we do MIDI 2.0 on Windows, and also at the same time boil the ocean for all the deficiencies that we've had in MIDI over the years to try to come up with a new stack for that, and started doing the engineering for that, and then worked with the audio team to get their folks involved and a bunch of other things. So it's been kind of a fun developer journey there. And I'm kind of back to where I started, where in college it was C++, plus plus, and now I'm back to C++ plus plus after, a long journey of everything but C++ plus plus for a couple of decades in between.
And I can imagine that experience across other languages also helps your C++ experience as well.
Yeah, s- you know, developers who have been doing C++ plus plus for a really long time might accuse me of writing code that looks either like C with classes or looks like C sharp, but with more pointers. Hey, whatever works, right?
Absolutely. And the audio software developer environment is really starting to expand out. I think that for the longest time, people were using mostly C++ for the back and front end development. But we were actually talking earlier about how there are some well-known audio software companies that use a mixed stack. You
Yep.
you had image line with FL Studio, a lot of people don't know that the front end is actually written in Delphi, right? And
Yeah, and that was something the last time I wrote anything in Delphi was in version 1 way back, and that's come a long way in those years too. But yeah, they use a mix of Delphi and C++, and actually Bremer's Audio, who make Multitrack Studio, that's another partner we've been working with MIDI. They also have it written in Delphi as well. So it's like the, it's not to diss on Delphi folks by any stretch, but I have not heard of anybody else using Delphi in any other industry these days. But here are two audio applications using it, so there must be something there that's appropriate for this.
yeah, absolutely. Yeah, now what audio developers are experimenting with and expanding upon is JavaScript with either C++ or domain specific language like C major for the audio engine. And that's starting to bring a lot of possibilities. Juice is going to be coming out with their next edition of Juice 8 with that's going to give a heavier emphasis on web views. So super excited to see that. And yeah, it's a very exciting world creatively for audio software development.
Yeah, more things to learn than ever, I think, is what it comes down to. I do like the idea of using web tech to try to paper over some of the differences in the operating systems there. Because if you're going to build a cross-platform UI, then I mean, there's already something that exists out there, and it's a web view across all these different platforms. So I can see why Juice might do that versus the OpenGL based stuff that they've been doing.
That's right. Great. So shall we jump a little bit into Windows and audio software development? So I have an outline that you kindly sent me
Yeah.
days
So
ago.
one thing I did want to start with up front, although I do see a couple of questions there, like wasn't FL Studio written in Delphi? Yes. And this wave sequencer is asked about code signing. I'll talk about that in a little bit, but for the most part, I'm gonna punt on that for a little bit. Just I'd say pay attention. On the code signing stuff, just pay attention for now. And I'll leave it at that. But on the optimization thing, like, so one of the things that, and I know this is the one thing I'm going to start with, and it's not actually on the list I sent you, sorry. But I remembered seeing that in your outline that a lot of folks think that you need to optimize the PC like mad to be able to do any sort of audio development on it. And really, there's a minimal number of things that you need to do. And then there is a whole lot of advice out there that will make your experience worse because it's like decades old at this point. And I keep reaching out to different companies and say, hey, this audio tweak guide that you've had up here since like 2010 doesn't really apply anymore. Like, have you tested this in Windows 10? Have you tested this in Windows 11? And it's like, no, we haven't tested it again. It's like, yeah, could you please do that? Because the advice you're giving people is like killing their performance and they don't realize it, or it's making it more difficult for them to like be able to use other things. So for one example of that is there's still a lot of advice. And before the chat says this, that all of my advice when it comes to tweaking is test it, see if it works. If it works, awesome, keep it. If it doesn't work, back it back out and like revert to where you were before. So if something works for you on your specific PC setup, awesome, as long as you know what it's doing. I don't like sort of the shotgun approach of apply these 300 things and hopefully something in there works because it just always causes like problems later. But one of the things that pops up a lot is, oh, go into your PC and set it to optimize for background services versus foreground services. Like it's a simple radio button, right? But what most people don't realize is that setting up your PC, like the foreground thing is any application that can be like rooted to a window that you have open is a foreground application, right? Anything that's like a Windows service or something running in the background is a background application. Kernel drivers and things that are running in the kernel are not background applications. We're only talking about apps here. So when you optimize, when you say prioritize background applications, what actually happens is you are giving all those different Windows services just as big a time slice as you're giving your UI apps. And then when you combine that with people saying like, oh, you need to turn off all these unnecessary services because they use up too much CPU. Yes, if you go in and optimize for background applications, you're giving them that extra CPU, right? So you're actually making the problem worse for yourself over time. There are some instances, very, very few, where this can make something work marginally better. But in most cases, not, because almost every AIO driver that people use loads in process with the client application that's running. It's part of the foreground application. It's going to be prioritized as part of that. And then if you're using in your applications any sort of MMCSS or real-time threading, it completely bypasses that optimization anyway. So all those MMCSS threads get prioritized basically like one stop below like the highest priority in kernel, and that's it. Like you don't have to worry about anything else there. And so what I did is I put together here, I'll share this really quickly. I'm just going to share screen. I'll share. Hello. Screen two. All right. All right. So I put together this unofficial. I say unofficial, and the reason it says unofficial is because um, one, it's unofficial, and two, because it's hard to have a blanket thing that works for every different PC. So one thing that Apple has in their favor is you have a finite set of devices that are supported and a finite set of configurations, and so you can write something and say, hey, this is going to work across all these, and I know it's going to work, right? The PC ecosystem is like you can build your own PCs, you can buy any number of different PCs. The typical PC you buy for gamer stuff is optimized for GPU and network latency. It's not optimized for real-time audio. And so things that you do on that one might be a little bit different from a general purpose PC. Like if you buy a Surface that has it's just optimized for general use and creative stuff, as opposed to like gaming, is going to have a different set of things that are going to affect it differently under the hood. And then the things that you do for a laptop are going to be different than the things you do for a massive tower that you have that's got plenty of extra cooling and whatnot. But I posted this, and it's aka.ms whack Win 10 audio tweak guide. And it's 3 parts. And if people want to see it, but it ultimately comes down to set your power settings, right? So a lot of USB devices don't understand um, being power managed, and so they just don't work properly. They tell us they can understand power management, but they don't actually work with that power management. So just turning off power management to your USB audio devices and USB MIDI devices, setting your power plan to something higher than the most energy efficient ones is probably what you want to do for real-time audio. And then there are some things that you can do related to core parking for some of the newer big little processors that Intel has put out. But otherwise, for the most part, you don't have to do anything. Like you don't have to go in and turn off tons of services or uninstall tons of things. There's stuff that you can decide to do it if you want to, but it's not actually using CPU time or anything like that. And so I just wanted to get that out there, that even for developers, like there's not a whole lot you have to do to the base Windows install to be able to use it for real-time audio applications. Okay. The
Fantastic.
Yeah, thank you. And that's controversial. Now, there are some people who do want to tweak them even further, and that's awesome. It's kind of the moral equivalent of overclocking your PC in the enthusiast and gamer world. If you want to get that extra X% of performance for audio, that's great. Personally, I'm not into that because that's not my hobby. My hobby is making music and writing code and doing things like that. It's not kind of PC optimization and tweaking the PC. So you can go as far as you want, but you don't have to go that far to be able to have a stable setup. Do you want to talk about developer setup stuff while we're here, or are there questions I should answer? Or
Yeah, I'd love to talk about developer setup. One of the most basic questions that I know that I had when I was looking at getting into Windows is what would what would a good typical Windows laptop minimum specification for audio software development? Do you have any type of recommendations on that? I ended up getting an Asus laptop that was actually a gaming laptop.
yep.
Had dedicated GPU. can't remember what generation processor that it had, but one of the more modern processors. Yeah. Do you have any recommendations on that for other people who are looking to get into this?
Yeah, and I'm going to share this. So again, reminder to the folks that I work at Microsoft. So as I share things here, just keep that in mind. One of the larger audio companies that I worked with recently, and I can't share their name, said to us, they came to us with the question, why is audio latency and DPC stuff reliability so much better on the Surface devices than it is on these third-party devices, right? That was them coming to us. I haven't measured this or verified it myself. I'm just going by what they said from their support experience. And there is some advantage to stuff that's developed in-house where we're writing the software and we're writing the hardware at the same time. It's the Apple model, right? They built a single unit all the way up. And so something like the Surface Laptop Studio 2, if you're going for a laptop, is a really nice device for that kind of development work. It's got a good screen, it's got a decent keyboard. You can have a discrete GPU to do more creative work on there, especially if you start working with AI workloads where you want to be able to do more like inference on the GPU and stuff like that. It's good for those things. The other ones is you know, you want probably minimum of 16 megs of RAM. I think 32 is really where most of us want to be for a lot of development work. But you can certainly get by with 16. I'm a big fan on if you don't need a laptop, a desktop is more economical. And I actually use both where I have my own built desktop here with an enormous I've got a 5K curved widescreen in front of me here that I use for development. It's perfect for all that kind of stuff. I actually have my PC on the other side of the wall, so I don't care about fan noises or anything. My cables go right through the wall. And I can make that as powerful as I want, and I can keep adding as much storage to it as I need over time. There's no limit as to that kind of stuff. So, I use synchronization to get any data to my laptop that I might need to bring with me when I'm going to an event or doing presentations or meeting with a client or anything like that. And so I just have different setups for different locations. And so I'm a big proponent of laptop on the road and desktop in the home or in the studio, but I know that's not for everybody. We also have uh, for straight up development, I'm going to share this with a caveat. We have some really good ARM-based devices for Windows that get long battery life. They're based on our partnership with Qualcomm, so they're based on ARM64. They're super powerful, right? They can do we have native versions of all of our developer tools for it, etc. The one thing that you're going to run into is there are not native ASIO drivers for ARM64. So if you can't use our inbox audio stack, then they're not good for audio development. So that's really the caveat on those. But they're a great, like lightweight, long battery life, no fan noise PC that you can use and bring around kind of everywhere, right? And so, and we'll be talking more about ARM64 and Windows here as kind of time progresses. But that's something to keep your eye on as well. We're not going the Apple route, which is a kind of a clean break. Like we still do Intel x64 and AMD as well. But ARM is increasingly more important to us for not just for consumer stuff, but also for more developer workloads.
Mhm. And
So I'd
can
say
you,
that, sorry, go ahead.
I was going to ask, when you get a moment, if you could also just briefly touch on, um,
Yep.
of course, Mac, you have Core Audio, it's the one thing that you just, that it's bundled with, but of course you have more options on Windows. And if you could just talk a little bit more on that.
I love how you put that. More options. Yes, that's how we're going to phrase that. Um, so this is one thing that Apple has done really well. They have Core Audio. Companies still create their own drivers in cases where they want extra performance. Like I know RME and a bunch of other ones create their own drivers that you can use on Mac OS. Um, on Windows, our inbox audio stuff, the latency isn't as good as you would get for inbox with Core Audio on the Mac. So just full stop. If you use Wasapi or our built-in stuff there, it's not going to be as good. It's certainly still usable for any application that can write to those APIs or uses something like a wrapper like ASIO for all, which sort of translates between the ASIO API to our inbox APIs, you'll get, the performance for development, I think will be fine. But you're looking at usually about 10 milliseconds or so or something like that, which, for musician use is not great. For development use is probably fine. For anything that you want to do better than that, then you're going to want to go with a vendor specific ASIO driver. Now, ASIO is a standard created by Steinberg, which is kind of for really, it's become the way to do low latency audio on Windows. It's a very lightweight way to go directly from the application to the hardware that you're talking to. And every audio device, or just about every audio device available for Windows that targets its market, has an ASIO driver available for it for Intel and AMD x64. And so those right now you have to go and get those from a vendor. We're looking at what we should do with this long term, quite honestly. So we have to balance the needs between the consumer scenarios for for audio reliability, and like the a musician knows what to do with an audio glitch, but a consumer doesn't know what to do with an audio glitch. Instead, they call Dell or whatever and be like, "Hey, my audio is glitching." They don't realize there's a buffer setting they can adjust or stuff like that. So we're looking to see like what are different options that we do in the future. Do we provide more um, power user slash musician level OS switches that let you kind of remove the minimum latency size, and you understand that you're going to have some glitches sometimes? Do we look at sort of using more things from ASIO in Windows itself? So there's a whole set of investigations happening there that there's nothing to share on those at the moment, but I just want folks to know we're aware of that, and we know the difficulty that imposes on people. But at the same time, we know that ASIO is kind of where it's at right now for all the DAWs on Windows when they want to have 1 millisecond RTL and stuff like crazy numbers like that.
And so this is going to show you how much of a beginner I am on when it comes to Windows audio software development. So you go to the Steinberg website, you download the headers for ASIO. And now, so for instance, I'm developing a standalone application. So now do I ship if I deploy my application, do I deploy it with those ASIO drivers, or how does that, or is it that, yeah, how does that work?
So the hardware companies ship the ASIO drivers for their devices, because there will be one specific to each of their device or family of devices. You don't ship that. You just write your applications to be able to speak to the ASIO API using those headers, but you don't have to ship any of that other stuff with it, right?
Great, great. Okay, so the headers just say, hey, we're using ASIO drivers for this, and it speaks to the hardware
Right. Yeah,
users machine.
usually your application will provide some sort of picker as to which one to which ASIO device to use, and then use the Steinberg APIs to open that device and start talking to it.
Got it. And you can force, for instance, if I try to use any of the other types of drivers, my application just doesn't, it just glitches and it's not acceptable. So can you force a user to need to use ASIO to
Well,
their application?
um, I mean, the application can, right? So that's fine. You can just say I'm only going to support ASIO, which many of them do. Um, the Wasapi stuff is not necessarily going to glitch. You have to look at it from a use by use case here, where if you're doing sequenced stuff as opposed to say recording vocals or a guitar, like the latency that you're going to get from that, especially if you open in what's called exclusive mode for Wasapi, is going to be pretty decent. So like it's not ASIO level, but it's usually good enough for many applications. In fact, for most beginner applications, it's more than enough, and they don't have to think about anything else. It's really when you start getting into high numbers of tracks and having like really low latency where you're doing real-time processing on vocals, or like say a guitar or something like that, or with high-level musicians that are going to notice a couple of milliseconds of additional latency, that becomes a real concern there.
Okay, interesting. So Azio is actually developed by Steinberg. And how do you, so let's say that there was a question here about um, new developments or where we can go in the future with Azio. Do you would you say that those discussions need to be directed towards Steinberg, or where's the place to direct that energy towards?
Um, I'd be fine. Like if they're, well, it's Azio, so they're probably Windows related. Uh, I'm fine with hearing like what people are looking for here. There's a perception that we don't understand that there's an issue there. And it's like, we do understand the issue. It's just we haven't fixed it yet in Windows. And fixed, I'm going to use air quotes around that yet, because it's more the decision that we have to make about which direction we go in which cases and stuff like that. But I'm happy to get feedback about ASIO, about audio latency. Um, Diagnosing specific audio glitching on an individual PC is probably not something I can scale to do in a reasonable way. I've done it kind of one-off with folks at a time, especially if they capture feedback hub traces in Windows that actually get us the audio data so we can watch the events as they happen and figure out where the buffer underrun is happening and stuff like that. But yeah, I'm happy to take feedback on that. Especially, because it helps me make cases for certain things internally, where if people are demanding, inbox something that's 2 milliseconds round trip latency in Windows, so it's competitive. If you put that in Feedback Hub and send me a link to it, that's evidence I can use that shows that, hey, there's a need for this. And whether it's some variation of Wasapi or something we do with Azio or something completely new, there's a need for this out here that people are asking for. It helps with our being kind of data driven on that.
Sounds great. Yeah, there was a question or an inquiry wondering why there isn't any new development on Oxio or Wasapi, and saying that streaming live audio can be difficult sometimes on Windows machines. So yes, so that's good. I guess that it would be good to hear just about their specific use case and
Yeah.
to get in touch with you. And I can put your email in the video description below.
Yeah.
Um,
That'd be fine. I'm going to hate myself for having done that, but I think that'll be fine.
mhm.
I would just tell folks to be so internally, what tends to work well when we're talking to folks is, don't tell us what the solution is. Tell us what the problem is. Like, what's the scenario you're trying to accomplish? So as opposed to saying, hey, inbox Azio, full stop, right? It should be more like, hey, I need to be able to have low latency audio in Windows for this reason, right? Something along those lines. There's a subtle difference, but it helps me bump some of these things up internally so people understand kind of like the needs behind this, as opposed to quickly dismissing a solution as inappropriate based upon on their future plans.
Mhm. Great.
Hey,
Well, yeah.
do you have more questions? Because if not,
Oh,
I'd like to just do a couple of dev PC setup things before we talk about MIDI, if that's possible.
oh, absolutely. Yeah,
Yeah.
please.
So I'll quickly go through a couple of things here. So one, I believe I'm still sharing the screen here, right?
That's right.
Okay. First of all, if you're a power user or a developer on Windows, you probably want PowerToys. PowerToys is where we um, prototype a lot of things that end up in later versions of Windows. So, for example, a lot of the Windows snapping stuff that we did in Windows 11 actually started in PowerToys for being able to arrange windows and different things. We've done like run dialogues, a bunch of other stuff there. So there are a few different ones here. There's a file, yeah, so there's like the file locksmith. Like if you've ever had, like, this developers run into this all the time. You want to know what file or what process has a file in use, and which can be really hard to find out. This thing like lets you see that and also lets you unlock the file so you can overwrite it again, which again is a big deal. So if you've compiled something and it crashed and there's some file left open and it's kind of like hanging, this will help you deal with that, which again, that's a super important thing. There are also things like if you're not familiar with the shortcuts in Windows, there's somewhere in here, there's a shortcut. Yeah, that's fine. It's one of the things in the list here. There's a thing that lets you quickly see all the different shortcuts in Windows. There is, oh, here it is, shortcut guide, right? So you can know all the hotkey combinations, which developers love hotkeys. So I think that's something that'll be useful there. There's also power rename on here. Yeah, so power rename. This is, I don't want to say this is kind of a band-aid over one thing that's a pain in File Explorer, but it's kind of a band-aid over a thing that's a pain in File Explorer, right? So this lets you rename a lot of stuff using different ways of renaming it. So if you have like just a ton of data files, we run into this all the time for like test cases and test data for different things, and you need to rename them a certain way. This makes it super easy to do that. So these are all things. This you download it right here. It just if you search for Microsoft PowerToys, you can grab it and you just install that, and it has all the other stuff on it. And so this is one of the things I would say is kind of an essential add-on.
Mm.
The other thing for developers, and if you have Windows 11, you may not realize that this is installed by default, but there's a tool called Dev Home, which is kind of the developer portal for Windows, where if you want to install different workloads or if you want to, simple things like there's like dashboard stuff here that gives you a couple of widgets that tells you, CPU, GPU, things like that. Things you can get elsewhere, but this kind of consolidates a lot of stuff together. And you're going to see this tool Dev Home show up at our build event next month quite a bit. So if you're I would encourage folks to catch the build event. It's free online. It's in the middle of May. If you look up Microsoft Build 2024, you'll be able to see that. You'll see a lot of things here related to Dev Home and some different developer productivity stuff that we're adding to that. And one of the things that I think is super useful in here, I'm going to say that it's pretty much essential, is this ability to add a dev drive, right? So if you're doing any sort of compilation, which pretty much everybody here, I assume, is compiling stuff on a regular basis that has lots of files, doing Node.js stuff, doing C++ stuff, any of those things. If you set up a dev drive, which is either a separate drive on your PC, or I believe you can actually set up it as a different partition on an existing drive, it installs our REFS file system on that, which is the resilient file system, which has been used in our kind of the Windows Pro for Workstation SKU, the big kind of like scientific one. And what that does is it gives you, I think, much better file performance or file IO performance under certain cases. And I mentioned one of them. The other thing it does is it removes most of our file system filters. So you can optionally completely turn off all virus scanning, but for the most part, it uses a more performant version of virus scanning that's optimized for this kind of workload. And so if you're doing a compile, like I have a dev drive set up on this PC, my GitHub repos are all on it, and that's what I use for doing all my compiles there. And it is much faster than what I was getting off my regular drives before because there's a whole lot less overhead. You sacrifice some safety, but we figure you're a developer, you know what you're doing. Don't throw random executables on there and torrent stuff to that drive, right? But if you go and use it for your GitHub repos and doing builds there, then you're going to find that it saves you a ton of time, a ton of time. And there's actually a whole there's an interesting little project going on right now. It's the Dev Drive Challenge, where they're trying to get people to try out Dev Drive and post their numbers. So it's kind of a fun thing, like what's your before and after compile time, like how much of a difference did it make, etc. The other thing that it adds to it with the latest versions of Windows 11 is copy on write, as opposed to doing just complete copies. So when you want to copy like an entire repo within that drive, it's just basically copying pointers, and it only moves the data itself when you go to write to that, which makes that whole process a whole lot more efficient. So I think smart things to do there. So that's something I would encourage folks to try out. The Dev Home thing is one of those, it's becoming more important over time, but it's really it's good for getting your machine set up to begin with. Like you can create configuration files. Like if you're in a company and you have five different developers and you want to be able to quickly stand up a workstation for a new hire, you can script all that stuff here and provide those as the standard machine configurations and be able to do that. So that's that. I think the other thing that I think a lot of people don't realize, let me pull this over. I'd say probably one of them. Oh, and I should probably, there's a setup a dev drive on Windows 11 if you want to see what the help is on that. And at the same time, there's some other documentation we have, which is guide for changing your dev environment from Mac to Windows. Read this however you want. I'm as OS agnostic as a Windows developer working at Microsoft can be. But like if you're moving from Mac to Windows or you are adding Windows to your other workloads, this has a lot of information here about how to open different things, whether the equivalents to different tools that are available on Mac versus Windows. So I encourage you to look that up as well. And I think we can post links in the show notes for this afterwards. So I'll make sure that you have all the links for that.
Fantastic.
The other thing I wanted to mention is Windows Terminal. So by default, Windows typically uses kind of the old command shell, but we have a much better terminal application, which if it is not installed, I forget which version of Windows we started installing it by default on, but if it's not installed by default on your PC, like if you don't see tabs in your command prompt here, then you can grab it from the Microsoft Store in Windows if you just look up Windows Terminal. And this has a lot more flexibility. Like it supports things like emojis and all kind of modern font rendering and stuff inside terminal, whereas the old one didn't. You can do crazy things like I mentioned where I started, right? So if I want to have here's my C64 shell if I wanted. No, I don't actually use that, but I think it's kind of fun to look at. So you can use whatever fonts that you want. It has, if you do like control scroll, you can resize things properly, etc. So there's a lot of just kind of things that you think, duh, you should have done this a long time ago that are actually in this that we never put in the old command shell because it would have broken all these applications that actually script out and screen scrape the command shell, which kind of kept us from being able to make changes to it. The other thing you'll see in this, which I think is super useful, is this is WSL. So this is the Windows subsystem for Linux. So this is a lightweight container, if you will, of Linux that runs on Windows. It's designed for developers. And it has, in this case, I'm running Ubuntu as a distro. You can run pretty much anything that you want as a distro. They're available through the store to make them easier for you to download and install that way. But it has all the, like I can do, nano, right? It has all the normal stuff you would expect here. I can do, it's got CMake on here. I can do help, right? So all these, yeah. Two dashes. I always forget which country I'm in here. Linux country. It's got all the stuff that you would expect to be able to do developer workloads. So if you're trying to move over from, say, Mac OS or from Linux, and you have Linux-based or Nix-based developer tools that you need to use, there's a pretty good chance you're going to be able to run them on here, or there's going to be equivalent of them that you can run here. And I think the other thing that's interesting about this that folks don't know is like you can run, let me pull this over here since it opened on my other screen. Yep. Come on, you. There we go. So you can run GUI apps side by side on Windows. So I have XEyes here, which is, really simple, but I can actually do GIMP if I wanted to, right? And so this is running side by side on Windows. Save file, new. Some of these things are a little weird, right? So I'm actually not a GIMP user, so folks are laughing at me, I'm sure. Whatever. Normally you can draw if you know what you're doing. I don't know what I'm doing because I don't, like I said, use GIMP and stuff here. And it's just kind of gimmicky to be able to run something like GIMP here, kind of. But if there are tools that you rely on in Linux and you're using a Windows PC for development, this is the way that we've made it easy for you to incorporate those as part of your workflow. So most of the stuff is related to being able to do, command line stuff, but all the things that we've done for adding in GUI applications is kind of fun. And I almost got Ardor 8 running from here, which, there's already a Windows version of it, so that's just really extra to do that. I was having some windowing problems, but the audio was working through Pulse Audio from that and forwarding to my Motu stuff on my PC here, so that was kind of fun as well. And then if you want to do remote remote debugging, we have an add-in in Visual Studio Code that lets you run your Linux process in WSL, and you can remote debug it from VS Code running on Windows, and it acts as though it was, it is all on the same machine. It acts as though it's on the same machine. And you might ask, like, oh, is this just running Linux in a VM on the PC? But it actually does a bit more. You saw you have side-by-side applications. There's also, built-in integration with the rest of the Windows file system. Your drives are all mounted, etc. So there's a bit more of a tighter integration there than just a straight up VM. Again, very developer targeted, not so much end user targeted. And I think those are the big ones I have for developer stuff that people may not be aware of. Again, we have build sessions next month that are going to cover a lot of topics that are developer focused. So I'd encourage people to check those out because there will be a couple of sessions in particular that are like, hey, here are all the productivity tools we use inside Microsoft for developing stuff, right? Take a look at that, and there might be some things you weren't aware of that are going to be really fun to have it. Okay.
That's fantastic. So going to that Linux subsystem, if I just want a command line interface that used a Mac OS or Unix like commands and do git bash, I could just do that natively within
Yeah.
that
Yeah.
window. That's awesome.
Yeah. Because I can go to any other place. Oh, excuse me. So all my drives, you see, this is why I have a desktop. I have many drives here. All my drives are there and available, and I can go to my C drive or wherever it is that I have my Git repo, and I can use that directly from inside WSL.
That's really cool.
All right. Do you want to talk about MIDI?
Yeah, I'd
Or
love
do
to
we have
talk.
questions that we have to deal with first? No?
No,
Okay.
I think we're good to go. Yeah, if you have any questions, by the way, in the chat, please let us know. But in the meantime, we'll go ahead and we'll move over to MIDI. It's exciting stuff.
All right. So very briefly, MIDI 2.0. So MIDI 2.0 is a new standard version of MIDI. It has been adopted for a couple of years now. You'll find that Mac OS actually has a lot of the plumbing for MIDI 2.0 already built into it, and you may not realize it, but if you're using MIDI on recent versions of Mac OS today, under the hood, it's actually using the MIDI 2.0 data structures and stuff for that, right? We're on Windows. We had a bit more work to do this because our older MIDI API is just not something we could extend, and it had a lot of deficiencies that people have told us about for many years. For example, it's not multi-client. Like you can't have more than one application using the same MIDI port at a time, which is an enormous limitation these days for MIDI applications on Windows. And so we decided that we want to get all of the kind of the goodness of MIDI 2.0 with its new data formats and its high resolution and better speed and everything there. And at the same time, make life better for MIDI 1.0 on Windows, right? So the new project that will ship before the end of the year inbox in Windows. And we're currently targeting the last version of Windows 10 plus the current versions of Windows 11. Is a complete rewrite from the back end all the way through to the API of MIDI 1.0 and MIDI 2.0 in Windows. Before, we never had a service in between in Windows. Like it used to be, the applications were essentially talking directly to the drivers through a whole lot of redirection of pointers and kind of like kernel mode switches and things like that. This one now has a Windows service where with some cross-process buffers that you can use to, send packets to the service, and the service is then managing all the connections to the different devices that are out there and being able to communicate with them. And it's given us a lot of flexibility in terms of what we do. So if in the past, if you wanted to create a say a virtual MIDI driver or something, a virtual MIDI device or something in Windows, you had to create a kernel mode driver or one of the extensions to be able to do that. And that's not the simplest thing to do, right? I'm sure there are more than a few folks here on the call who've written drivers. They're kind of a pain compared to working in user mode in terms of like what you have to do to get set up and what you have to do to debug and what you have to do when you constantly blue screen your PC because the driver's misbehaving, right? And so we wanted to make sure that we had an extensibility model built into this where if you don't need a driver for something, then there's no reason to write a driver. You can instead write a component that plugs into our service. So for example, I've started writing our Bluetooth stuff, which I'll talk about here in a second, which is a rewrite of our Bluetooth stack. That doesn't need a special driver because it just talks to our Bluetooth APIs. I have app-to-app MIDI in there, which is built in as an extension in the service, a component in the service. I have MIDI 2.0 virtual device MIDI, which is something new and has a bit more to it that I can always talk about, which is again another component in there. And then we have our USB MIDI 2.0 and 1.0, which is a component, but it also does have a kernel mode driver because that's talking to USB devices at that point, and we want to make sure that works well. And then we have in development network MIDI 2.0, which is a specification that the MIDI Association is almost ready to adopt. And we want to make sure that we're able to support that in Windows as well. But all of those are written as kind of extensibility components inside the service, and they show up just as normal MIDI devices. And so let's see if this works. So there's a new command line tool in MIDI, and stop me if I just keep going here and you have questions. Feel free to step on what I'm saying here. This is our new console tool that comes as part of Windows MIDI services. And so you can do pretty much anything with MIDI here. So I could say MIDI enum endpoints, and it's going to list here are all the endpoints that I have available to me right now. And I mentioned that I'm working on Bluetooth, and here's where my PC may crash. So I'm gonna risk this anyway, in which case you may have to do a song and dance if this happens, because this is very much in development. But I've got an Orba here, which, thanks to folks at Artiphone for creating such a cool device. I've started working on the Bluetooth stuff here. Let's see if it's been picked up. Yep, there it is. So there's the Artiphone Orba 2 now shows up as a device that's on there. And I can turn it off, but I'm not going to because I don't want to get kicked out of the call right now when I do that. But you can see that I have access to those devices there, and it's just being picked up by the service. I can also do, let's say, MIDI endpoint monitor, right? And then I can pick, oh, I want to do the Iridium. And actually, I didn't try this. Let's see, is this going to come through? Yep. So here are some MIDI messages that are coming through from the Iridium. And this is multi-client, so I can have multiples of these open. I can have this monitor open while I'm, using an application, etc. Somebody else had asked on the Q&A, what about, app MIDI, and what about the virtual devices? So let me uh, pull up this sample. I'm going to run this right from Visual Studio here. I know I'm off screen, but I'll drag it on here in a second. So one thing that's important to know about MIDI 2.0 is there's this bidirectional communication between the devices. So in this case, between the PC and the actual device. And when you connect a MIDI 2.0 device, there's a negotiation that happens when it first connects. So we have to go out and say, hey, what protocol do you support? What functions do you have? What do you name yourself? All that kind of stuff. So there's this like communication that has to happen when you first connect a device. So if you want to have proper app-to-app MIDI, then you need to be able to emulate that as something that the application provides when it's like acting as a device. So in this case, I have this device here that's just I call pad controller, right? And it just our normal grid of things, and that will show up. So num endpoints. That will show up here as an application that you can connect to through MIDI. And when it first connected, it did that negotiation. It said, here are my functions. Here are the different things that I can do. And then applications use that information. So let me pull up another application here. Sorry, it takes a second. Oh, there it is. Okay. So this is Bremer's multi-track studio, which he's been working with us on implementing the MIDI APIs in Windows. So if I go over to Studio here, and this is a pre-production prototype version. So the things that you see here aren't necessarily representative of what it will finally do. But if I go to devices, you see here's the pad controller app, and I see that it has pads output and this random one called a function block at the bottom. And I realize that's probably pretty small, right? So that those two things there are defined by the function blocks that application produced during the original negotiation. So that bidirectional communication that went in, we said, what do you call yourself? Said pad controller app. Okay. What are your functions? I said, well, I have two functions. I have this pads output and I have this other one that I have as a test just called a function block. And those were defined in the code that you use to create this pad controller application. We've provided properties that say, and functions that say, add a function block, set my name, do these types of things. And then we handle responding to those requests for you so that when you've set these properties and the other application says, what's your function blocks? Well, we know what they are. So we send them over to the other application that's connected there. And then they can then use that. And so if I hit OK here, and if I want to add a MIDI track and just go through and double click on that. And if I want to record that, sorry, it's all the way up here. Right. So we can see that we have app to app MIDI working there, but also importantly that if I go here, MIDI endpoint monitor, and I go to the pad controller application, then I can also see those there. And it's still going through to the Bremer's application as well. So again, multi-client, which for folks using the Mac is not a big deal. For folks there who are used to the way Windows MIDI works, this is kind of revolutionary at that point. So being able to have all this stuff built in. And then, so the pad controller application is a free sample that we have up on our GitHub repo. I should mention all of the Windows MIDI services stuff we've done has been developed in the open on GitHub. If you go to aka.ms whack MIDI, that gets you to our documentation, which also gets you into the repo and stuff there. So you can see the source for everything that we've done here as well, even though we're ingesting it to ship it inside Windows itself, right? So it's a kind of a newer model. But the source code for the pad controller application is available on there as well. So let me close that. There's a whole lot of other stuff that you can do through this application, like you can send a file of data. Like if you want to send a sysx dump, you can send that through here. You can use it for testing stuff. There are lots of, you can script out like command line stuff. So if you wanted to have a set of messages that always gets sent when you're starting up a performance, or when you're like, you know, you're starting up for the night, you can script those out if you want to, and then have it make multiple calls to this to send those messages out to those different devices to say, change to a specific patch, you know, set some parameters on that patch, do whatever it is that you need to do. So we tried to make this fairly flexible as a power user tool. The other thing that we have that's related to that is, excuse me, there is a MIDI settings application, and this one is in slightly rougher state at the moment here. This is the other application that's focused more for less technical or kind of less power users type folks, where if I want to look at my different devices here, I can see that I have, you know, the Artifun, the Orba, I have the Iridium here, which is a MIDI 2.0 device, and I can get specific stuff. This is where I can rename things. I can set the description. I can associate images with that. This isn't the final UI for these, but you can see basically how this all works. And then here's a permanent loopback MIDI stuff that I've created in the configuration file versus the stuff that applications can create. And speaking of which, the configuration file where we store all the custom names, permanent loopbacks that you might want to create, relationships between things, custom properties, which images you might want to associate with a device. That's just a JSON file that we store in Windows. So you can take that and move it. So if you have like a performance laptop that you bring with you, you can take that and copy it to that performance laptop with the same devices connected. And all of this customization information will just automatically go over with that because it's in that configuration file. And you can also have multiple configuration files if you want to have more than one type of setup inside your PC at any one time. So lots of flexibility there. And of course, the devices and everything they were talking about, they show up just like normal MIDI devices or I should say, they will show up as normal MIDI 1.0 devices for applications using the old APIs. That's the biggest piece of work that we're working on right now. Specifically, Gary and team on the audio team are working on to repoint the older WinMM and WinRT MIDI 1.0 APIs to talk to the service so that they can get some of the benefits that we've had here, like multi-client and other stuff. They won't get MIDI 2.0 because we can't, change those APIs because the data format is completely different, but they will get some of these other benefits there.
Fantastic. So we have a couple questions.
Yep.
One is, does this support MIDI MPE?
Yeah, so we haven't done anything special for MPE, but MPE works just fine. There is also a MIDI 2.0 profile for MPE that's either in development or has been developed. I forget which, but specifically for devices that want to support MIDI 2.0 as well as MPE. But all the stuff that you can do in MIDI 1.0 today, you can do here. I do want to note that the new API is 100% based around the new MIDI message format, the UMP, the Universal MIDI Packet. And so even when you're sending to a MIDI 1.0 device, your application still sends a UMP, and then we do any required translation behind the scenes. On the plus side, it's very easy to package up a MIDI 1.0 message in a UMP. If it's not a massive string of sysx, that takes a little bit more work to do. But all the other messages have a very clean translation to get them in there because there's a MIDI 1.0 protocol format for UMP.
Fantastic. And looks like there's a question in here. Just going to read what it says and
Okay.
So it says, so no more MIDI cable, just USB or BT. This sounds really good to me. Clocks and signals are better / easier synced between devices. Hardware sync to tracker to clock.
Yeah, so I think they're talking about the DIN cables for MIDI 1.0, right? So the classic 5-pin DIN that's been around since 1983. Yeah, I mean that protocol, that wire format, if you will, it's slow. A lot of people don't realize that a single note on message on MIDI 1.0 over DIN takes a full millisecond to send. So if you have a chord with 5 notes in it, that's 5 milliseconds from front to back to send note on messages. So when we're talking about latency and jitter and things like that, that's assuming that there's no other data going across any other channels on that same MIDI cable. So they are fairly slow, right? And that's really just the nature of that protocol, regardless of what it's connected to. Those are still supported. So if you have a MIDI 1.0 device that's connected to the PC through USB and it has DIN cables on the back and it exposes them through USB, we still support those like we do in MIDI 1.0 today. But for MIDI 2.0, there is not currently any point-to-point serial connection defined. So there is no DIN cable equivalent. What I think will become the replacement for that is the network MIDI 2.0 protocol, which can just use an Ethernet cable or Wi-Fi. And Ethernet cables, can be like 300 feet long. So that's really great for that use, and they're well defined, and they're a commodity item, and they're something that most microcontrollers can support. So I'm actually looking forward to seeing more networking built into these devices in the future versus kind of the old DIN cable approach.
Fantastic. Let's see. Looks like that's it on questions. I did have a question that's on MIDI 2.0, but maybe a little bit off the beaten track.
Sure.
Can you talk a little bit about some of the innovations that you've seen manufacturers come out with using MIDI 2.0? Has there been anything that that you've seen that
Yeah.
you've thought was particularly impressive or particularly in the direction that you were thinking when creating the specification?
Yeah, there are they are we often describe it in the MIDI Association as MIDI 2.0 is just more MIDI, which is really kind of what it is, where it's less revolutionary and more just taking the things that people have been doing over years and making them better. So, for example, um, the first or some of the kind of innovations in MIDI over the years were adding in MPE, for example, is one, or people doing more with polyphonic aftertouch or stuff like that. But really, MPE is a good example because it breaks up the notes and sends them out on a single channel per note, and does some things that MIDI was not designed to do, but it could be adapted to do. Um, where MIDI 2.0 formalizes a lot of that so that you don't have to use up all your channels and all your groups to send, polyphonic expression and whatnot. There's a lot more there to make it easier for you to be um, flexible in creating these new types of devices. Like another thing that's added on is there's the new orchestral profile, which the note on message can contain information about like which direction was the bow going on the violin, right? So that's part of the note on data that you can capture as part of that. And that stays with that data. So if you think today, when you're capturing that type of information in a DAW, you have, oh, here's the MIDI message, and here's all this other metadata that we have with it. And oh, by the way, this other metadata is very plugin specific in terms of how it's used, right? So standardizing that is one of the kind of the big benefits of that, where now it's just encapsulated. It's all in the MIDI message, and you can now track this as a single atomic unit and move it between plugins and move it around your DAW and store it like that. So that's, I know that's not the question you asked, but like that to me is like one of the big things that I've seen coming there. The other one is just I'm not a pianist, and so when I see people, I just have to like nod and smile that they're in fact seeing like what they say they're seeing. Um, but just the additional levels of velocity sensitivity and the way that the curve can be adjusted using MIDI 2.0, where because you have, MIDI 1.0, like a note on velocity is somewhere, 0 to 127 because we use 7 bits to capture the data and that's it. MIDI 2.0, you can use 16 bits or you can use 32 bits. There's actually quite a bit of flexibility there in terms of how the message is structured. Uh, and that gives you, when combined with what's called the piano profile, that gives you a lot more flexibility for how you map that curve and where the different points are on that curve. Because a musician can tell the difference between, like 90 and 91, if they're a pianist, because there's on a lot of those ones, like they might fall on a point on a curve where there is quite a bit of variation between 90 and 91 on the velocity curve there. And so seeing some of the people at NAMM playing the device both with I've actually got one here. It's a Roland A88, but trying it in classic MIDI 1.0 mode and then trying it with the piano profile and UMP with the higher resolution, they saw just such a massive difference in the way that they were able to play because to them it was much more like an actual piano as opposed to a digital representation of the piano. Like the sample libraries and all that stuff, they've been doing all this work forever, but they've been hampered by the fact that the data coming in is still quantized to that 128 different steps. And so there's only so much they can do with it. And so that's really really one of the biggest things there.
Fantastic. There is one more question, and I know that you said a little bit earlier that you were going to punt on this one, so but if you could offer any nuggets just regarding code signing for Windows, there.
Shoot, sorry, I lost audio here.
Oh, are you there?
And that's that beta code stuff I was talking about. I knew that would happen. I song and dance for 1 minute. I will be right back.
Okay. So Pete, while Pete's coming back, I'll go ahead and I'll ask him about the code signing.
Let me get out of here.
And um, I'm going to ask him about the code signing. In the meantime, just in case you might be joining in the middle of this, please join us on our audio programmer community on Discord. So we're getting towards 11,000 members on our Discord now, and you can join on theaudioprogrammer.com/community. Okay, you're back. Yeah, that was smooth.
Yeah, sorry. We were joking about this ahead of time, and I explained like I have a significant amount of non-production code running on this PC right now. And I know that one thing that happens to me once in a while is my audio gets a little out of sync and it starts sounding robotic. So that's what I was having to deal with there. Anyway, I'm assuming you can hear me okay.
Yeah, yeah. You can hear me, right?
Yep. Yeah.
Okay, great.
And
so I know that you said that you were going to punt on this a little bit earlier.
yep.
Somebody had asked again just regarding code signing for Windows, and I know that this has been a point of many questions just in our community. I see it daily on the Discord that there are these new requirements coming down, and that people had heard that there's a new service that would avoid the need to use third-party certificate vendors like Sec2Go, and wondered if there's any type of nugget that you could offer us or any type of
So
hope. Maybe I should say hope.
um, don't give up hope. So first of all, uh, there's there's really nothing I could say about it at the moment, but this is the kind of thing that if we were going to talk to developers about it, we would be talking to them at build.
Yeah. Okay, great. So attend build. And when is build again? It's next
Uh,
month, right?
yeah, it's next month. It's like May, it's the week of May 20th. So it's like
Great.
Tuesday, Wednesday, Thursday.
Yeah.
Right.
So
And no promises on that because I'm actually I don't remember what exactly, if anything, we're saying about code signing, but that's where if we had something to say, that's where it would come out.
okay, great. So let's hold off until May 20th and hopefully people will get the type of answers that they're looking
Yeah.
for.
And yeah, I
Uh
totally get like code signing and being hit with um the I forget what it's called actually now though. The dialogue that comes up and pops up and says, yeah, do you really trust this person? That doesn't help applications, so we understand it. The
yeah.
other thing you can do, by the way, and this isn't going to help some desktop applications, but if you created an app that you package and put in the store, then you get signing kind of for free as part of that. But it's restricted in the types of applications that can be signed that way. So it's a little bit less appropriate, I think, for audio folks.
We have a question from Simon who asks, how do virtual MIDI ports fit into this new ecosystem? You create a virtual device, then add multiple virtual MIDI ports to it, or each virtual device is just a virtual MIDI port as such?
Right. So MIDI 2.0 does not have the concept of ports. So let me start with that because that's probably a big deal for folks. And let me share this screen. MIDI 2.0 doesn't have this concept of ports. So ports are kind of a fabrication on top of, I'm just going to say cable numbers in USB MIDI today, where a device, a MIDI endpoint can have 16 cable numbers. And then behind the scenes, we translate those, even though they're all in one stream, we translate those to MIDI ports that we expose on Windows, right? In MIDI 2.0, there is no longer that cable number thing. Instead, it's what's called a group. Now, these are not exactly one-to-one, but I think, for sake of discussion, they're close enough. And each message that you send is targeted towards, a group from 0 to 15. and then a channel from 0 to 15. And effectively, what that does is it multiplies the number of channels that you can have on a single device. But realistically, what happens is now what used to be a separate port is now part of the message itself. And so we don't expose the port, we have to expose the endpoint, and then you provide that group as part of the addressing inside that universal MIDI packet message, right? And so when you create a virtual device using the code here, let me see if I pull this up a little bit. I did this one in C#. You can certainly do this in C++ as well. When you create this virtual device, um, that becomes a single endpoint for that application. And then you can decide how many of those groups are active. And the way that you do that is you define what's called a function block. And if you see here in the code, I
Oh, you
say,
gotta share your screen again, by the way.
oh, I'm not, oh, it says it was sharing. Oh, let me do this. Oh, that's why. It's just outlined. Sorry, I'm a Zoom newbie. All right. So here we go. So I assume you can see it now.
Yes.
All right, thanks. Thank you for that. So this is the code here. It's all in C#. So you can see that the function blocks that I've created, this one says first group index is 0 and the group count is 1 for that function block. A function block can span multiple groups. So you can say, I have a synthesizer function block that has two different groups, effectively giving it 32 channels of data that it can process, right? And so that's a MIDI 2.0 a MIDI 2.0 construct. And so what we do here is we say first group index is 0 and the group count is 1. You see, this is that pads output that we looked at earlier inside the Bremer's application. And then I have a second function block here, which is group index 1, which is the second group. And it is also a single group here. And so that's how you define for that virtual device. Here are all the groups I have, which morally equivalent to ports, if you will, in MIDI 1.0 in the past.
Right. So we have another question. Topic of being able to combine multiple audio interfaces into aggregate interfaces. Is that possible on Windows? Apparently, it's possible on Mac OS.
There's you can with some caveats, right? So there's a third-party driver called ASIO for all, which is kind of a wrapper library that'll let you aggregate some interfaces. It has some of the same problems that you do on Mac, where sometimes getting the clocking right is a challenge for across those different interfaces. But it does let you do that. The thing is, it's not something natively supported, and it does add a little bit of latency to it. But it's something you can do. It is a request that we've heard for audio aggregation, and it is on the list of things that we're considering when we're looking at where we kind of need to take the audio stack going forward, but nothing to say on it yet.
Okay. P. Pitty asks, can the latest MIDI APIs render MIDI to PCM with custom patches?
There's nothing built in for that. But if somebody wanted to build an application or even a custom output that would do that, sure. But no, we don't have any rendering like that.
Okay. At Sushi, all the way from Japan, asks, can we send UMP stream messages by ourselves to achieve what these function blocks classes would be internally handling?
So yes, you certainly can. We would encourage you to use the stuff we've built in, but we don't require it. What happens behind the scenes is in the service, we have a process that captures those stream messages as they come by, and then we update the software device properties with that. Now, we don't eat that message. We send it along so everybody who wants to see it can see it. But we do some internal synchronization to keep that information up to date. The other thing to keep in mind that if you use the new if you use the app-to-app MIDI / virtual device MIDI stuff that we have here, there's code in it that controls the lifetime of the of the endpoint that's available for applications to connect to. So because we have two applications, we actually need to create two endpoints. There's one that the device application talks to, that's a bidirectional endpoint, and then there's one that's available for all the other applications to talk to. And what we've done is we've made it so that if you're using our code here, and it doesn't have to be the function block code, but at least the rest of the code, this one for public applications only appears once you've finished the setup and you've actually connected to that device from your application. And then if you close that connection, then the related connection also disappears. If you use just our straight app-to-app MIDI, which is simply a loopback where our applications can just talk to each other without any additional control. You can do anything you want, but we don't control the lifetime of those connections in any way like we do for the virtual device approach.
Okay. Looks like that's all of the questions.
Well, I
Anything
did
else?
see one here. Let's see. Audio routing. Oh, sorry. That so no more MIDI cables, clock and signals. Duh. Oh, I should mention that on the MIDI side of things, um, there's been much said about MIDI jitter in Windows in the past, and I'll just throw on that I've measured it. It's not what people claim. It's actually well within. It's in the microsecond range, and I think a lot of what people were seeing as jitter is either really, really old stuff, or maybe there are some bad devices out there, or maybe they're just looking at the different MIDI messages that come through and not realizing that they're all serial and they come one after another. That said, even though that jitter was, well below, I think what folks are claiming, the jitter and the latency in MIDI 2.0 is even lower, because there's no cap on speed anywhere, right? So if you have whereas MIDI 1.0 is going to max out with a excuse me, a USB one, like what, full speed or whatever connection. MIDI 2.0, if you have a USB 3 device, we will run it at whatever device that supports. So if it supports USB 3 speeds, we will, give and get data from it at that maximum speed. There are no caps anywhere. There were never any caps in Windows itself for speed to quantize it to, 31250 or anything like that. But that approach is faster. The other thing is that our actual process for transferring the data now between, even though there's a service in between, we get the data to the kernel driver faster than we were with MIDI 1.0 in the past. Anyway, so that whole thing there is just a heck of a lot faster than what it was before, even with adding in things like we have translation. We're adding in things like sort of old MIDI mapper stuff, where if you want to do message processing in the service to be able to, remap notes or do things like that, we're trying to make that available probably in the version after our first release, but a lot of that infrastructure is in there. Yeah. Anyway, so it's generally faster and more capable.
Great. I think
How
that's all the.
much has the audio engine changed in Windows from Vista? A bunch, but you'd probably want um, Gary or somebody else who knows the audio engine much more intimately than I do to talk about that. But there have been a bunch of changes. It's just the API itself is very similar. If you think about it, like for musicians, not so much, but all the work that was done for spatial audio and all the things that had to be done for surround and mixed reality and a bunch of other stuff there all became part of that. Valentin says dev drive is quite buggy. I had to delete the whole partition in the end. I'd love to hear more on that so we can send that feedback to the team. So Valentin, if you want to email me, go ahead and do that, because I know the folks on that team, and we can get them to take a look at it and find out what's going on. And USB ground loops are a thing. Yes, they are. Code signing we answered, and yeah, I think that's all of them.
Yeah, I believe that's everything. Pete, thanks so much. That was very educational.
Thank you. And I'm always available if folks have other questions. And then I'll just plug a couple of URLs if they want to learn more about MIDI on Windows. It's aka.ms whack MIDI. And if they want to learn more about the internals of what we just did, I did a podcast that was put out this morning, I believe, actually, with a guy in Australia that I work with a lot. And that's at aka.mswac Dawbench. And Gary's on that one. And he talks about more of the internals and the technical stuff there.
Fantastic. Yeah,
Cool.
if you could send me the links to all those, and I'll be sure to put those in the video description below, and I'll timestamp all of these up and everything.
Cool. Thanks.
Great. Pete, really awesome talking to you. Thank you so much.
Same here. Thanks for having me on. I really appreciate it.
Yeah, and as I said before, for anybody who wants to continue the discussion, please join us on our Discord community, theaudioprogrammer.com/community. We have nearly 11,000 people, 11,000 developers from all around the world that are there discussing. So please feel free to ask and share your knowledge there afterwards. And we will see you in May, the second Tuesday in May. I don't have the date in front of me, but I
Right.
will be announcing it soon.
Cool.
With that, we'll go ahead and sign off. Thank you, everybody, for tuning in and for the fantastic questions. And we will see you next time.